Okay, so here's light in the photovoltaic cell in the sunlight. We have to angle the panel to face directly at the sun. Now you can use the shadow of a pen to do that as a simple way. So the angle of the sunlight depends on various factors: the time of day, the time of year, and your latitude on planet Earth. Okay, so right now I have this at 11 ohms. We're getting just over 8 volts, and we're getting over 500 milliamps, so 0.5 amps. So on the meters, we have to be careful. We have to switch to the 10 amp setting first, because the milliamp setting is fused at 500 milliamps. So we're over that number right now. So on digital multimeters, when you're using it as an ammeter, you always have to be aware of that. Okay, so we can try various values and see what happens. So now we're going to go to 31 ohms. So we saw the voltage jump, the current dropped. Okay, and we're going to record quite a few of these values, and we're going to find the peak power output dissipated in the resistor, and we're going to also calculate the efficiency in this case. Now at best conditions, the intensity of the sun is around 1,000 watts per square meter. Now this is on best conditions. That means no clouds in the sky, and usually when the sun is directly overhead or the panel is directly facing the sun. So peak conditions usually means at the time of year that is best for your latitude. Okay, so if you're at the Tropic of Cancer or Tropic of Capricorn, that's going to have to be on June 21st or December 21st on the solstices, is when on those latitudes you have the peak conditions. Or if you're at the equator, on the equinoxes, March and September. Okay, or anywhere in between that your latitude lines up with the time of year. And we are going to find the best efficiency, the best power output to calculate the efficiency using the sunlight. Now this value might be more precise than the value using the light bulbs, as we did in the lab, because the intensity of the sun is constant throughout this region. Since the sun's so very far away, the light rays can be approximated as approaching parallel to the panel. Okay, so that should cover light in the photovoltaic cell. You can look at the data, and we will try to make this work, and we will hopefully get a decent value of the efficiency of this panel. Now keep in mind, very few panels go above 20% efficiency. I doubt this one's at that, so that kind of gives you a ballpark of where these values should roughly lie. Probably less than that. Okay, so that should cover light in the photovoltaic cell.